Alrighty, so we've taken a look at the two main adapter types in the Android SDK that we can use kind of out of the box. There's actually a third one called the cursor adapters, but we haven't talked about cursors yet, so I'm not going to worry about that too much. The cursor adapter is very similar to the simple adapter, except it uses a cursor instead of an array. What I want to do in this video, though, is I want to create my own adapter. I want to show you guys how we can achieve the maximum flexibility in a list view. And doing your own adapter actually opens up a lot of really cool possibilities. Like, for example, you can have different kinds of views in list items. You can create list views with headers and collapsible headers and all of that fun stuff. And you can do that all by creating your own adapter class. So I want to show you guys how you can create your own adapter class, and what it's basically going to do is I want to take this code right here that you see right here, that we're using this simple adapter, but we're also using this weird array list of hash map of string and string thing with these two other weird array things, and we're kind of munging them together in the constructor of the simple adapter. What I want to do is I want to create our own adapter that understands customers natively. So our own adapter will allow us to basically radically simplify this code while affording a lot more flexibility in how our views, our individual list views, are created. So yeah, that's what I'm going to do. Basically, we're going to create the adapter first, or a simple version of it, and then I'm going to replace all this code with using our new adapter. So what I'm going to do is I'm going to right-click my package, select New Java Class, and I'm going to say Customers List Adapter, or Customers Adapter, or whatever you want to call it. And he is going to inherit, in this case, he's going to inherit from Base Adapter. Now, Base Adapter is basically what it is it's an implementation of the List Adapter interface. The List Adapter interface is the adapter that you're supposed to implement, or the interface that you're supposed to implement so that your class is compatible with the list view. And the base adapter is the simplest implementation of a adapter. And as you can see, it doesn't really contain any functionality. Don't worry about what these individual methods do. We'll talk about the ones that are important. But you see that it contains really just stubbed data. So that's what we're going to start off with. We're going to start off with the base adapter. That being said, you are free to start off with whatever adapter you want. Like, for example, an array adapter. An array adapter, if you started off by inheriting from an array adapter, you would have fewer things to implement if your particular use case is more similar to an array adapter. In this case, I'm extending from the base adapter, so I show you guys exactly what lies at the root of all adapters, exactly what the minimum possible amount of things that you have to support in order to be an adapter. Now, before I implement or stub out the abstract members, I basically want to sum up what an adapter does. And an adapter is simply responsible for creating the individual list item views from data. What data? Well, that's up to the adapter. That's why it's very powerful to create your own adapter. So let's go ahead and do that. I'm going to hit Alt-Enter, and I'm doing this, by the way, with my cursor adapter on the squigglies. And that'll bring up my quick fix window, and I'll hit enter to say implement methods, and then I'll hit OK. So what you're looking at right here are the 4 methods that are required for you to implement in order to create an adapter that can talk and communicate with a list view. Get count, get item ID, and get view. Get count, well, it returns the amount of items in this list view, or in this data set, in this adapter. Get item is basically it returns an object that represents this particular item. Now, the get item method isn't going to really affect how the list view itself behaves, but as we'll see, it's a very, very convenient method. So it gets an item position and returns an item object. Get item ID is a silly method that I wish had a default in the base adapter, because for the list view to work properly, it needs to get a unique ID for every item in the list. And as it turns out, you could just use the position as the item ID, and that will work just fine. So almost always our get item ID will simply return the position as the ID, so it's not important. However, the most important method of this class is the getView method. Now, what does the getView method do? It returns an instantiated view for that particular list item. So it returns a particular row. This is where you would inflate your layout, set your text views up, and do all that fun stuff. So yeah, that's basically how this class works. We could, we could keep things simple and say, and not even tie this up into a backing interface. Like we could say get count, and we can get count return 3, and then on the get view we could say if position is 0, if position is 1, if position is 2, return this different view, and so on and so on. But in this case, typically list adapters are going to be backed by some sort of data structure. In this case, we're going to use an array. So what I'm going to do here, the customer list adapter, the data that we're going to use is I'm going to say, up at the top, I'm going to say private final array list customer. And I'll call this customers. And then I'm going to create a constructor. And I'm going to do that manually so we don't get a parameter. And I'm going to say customers equals new array list. So this is going to be our data structure that will back all of our adapter. And what I'm going to do here is I'm going to create a public void add method, customer, which will simply say customers.add customer passed in, and it'll also say notify dataset changed, and we'll have a public void remove customer, and then we'll say customers dot remove, passing in the object customer, and we'll also say notify dataset changed. So in this case, our adapter is really simple, and it's very, very similar to the array adapter. In fact, I could have used the array adapter as a starting point, but I really wanted to show you guys what the base adapter does, how the minimum amount of methods that you're required to implement to make your own list adapter. So in this case, this is our data. Our data is simply an array list. We instantiate the array list on construction, and we have two methods for publicly manipulating the array list. And as you noticed, we invoke the very important notify dataset changed method on both the add and remove methods so that the list view gets notified that it needs to refresh its adapter. So now let's do our get count. So our get count, I'm going to say return customers dot count. Or length. Where are you? Size. Wow, sorry, C#. I was like, get count, I'm suddenly in C#, and then I was like, yeah. So, size. And now let's go ahead and implement our get item method. But I'm going to do something interesting with get item. So, in Java, you can, when you override a method, you can change the return type of the overridden method as long as the thing you're changing it to inherits from the thing you're changing it from. Meaning, I can change the return type of this method to customer. And that's because customer is an object. So if we were to cast customer's list adapter to a base adapter and evoke it that way, we'll still be eating objects. But if you have a reference to the more derived customer's list adapter, I'm going to return a customer out of the getItem method. And that'll just clean up some code that we would typically have to put in a typecast for, and we no longer need to do that. Then I'll say customers.get at position. For getItem ID, like I said before, we're going to just return position. Anyway, what you're seeing right here is pretty much the most simplest form of a list adapter that you're going to create. So you have an array, some sort of backing data structure, you have your count method, your getItem method, and your getItem ID method. The really fun stuff starts to happen in the getView method. Now, for the getView method to work, I need to create a new view. I need to inflate a new view, fill out its individual items in it, and then return it. So in order to inflate a view, what I'm going to do in this case is I'm going to receive a context object as a constructor parameter. So I'm going to go up here to the top of the customer's list adapter, and I'm going to change its constructor to have to get a context. And then I'm going to say private final context as a field, and then I'll initialize that field to that constructor parameter. Now, why am I getting a context object? Well, I'm getting a context object to get a layout inflator. So I'll go ahead and I'll cache that as a local, I'll alias it out to a local field. I'll go ahead and do a layout inflator, layout inflator, and then I'll say this dot layout inflator equals context dot, or whoops, equals layout inflator dot from context. So really all I'm doing here is I'm getting an instance to a layout, I'm getting a reference to a layout inflator so that I can create layout files. I'm getting it from a context here, and that context is going to be satisfied with an activity object. And the reason I'm doing that is the layout inflator needs to know the theme of the current activity in order to work. So for this context parameter, be sure to pass in an activity and not an application object, because both activities and application objects are indeed contexts. Anyway, now jumping down to get view, we can now fill this method out. So what I'm going to do here is I'm going to say view equals layoutinflator.inflate, and I'm going to pass in r.layout.listItemCustomer2. So this is that same view that, oh, well, I also will need to pass in my view root, which is going to be parent, and I'm also going to pass in false for my attached to root. Now we do that because we don't want this view to be automatically attached to the parent, but it needs to know where it's going to be eventually attached, so we have to specify that additional parameter so that it can do proper dimension sizing. Okay, so now that we got our view, what I can do is I can extract out my two items. So if you recall, we have two text views, one with the ID of list item customer to first name, and one with an ID of list item customer to last name. So let's go ahead and extract those out. I'm going to say text view first name equals view dot find view by, oh, of course I need to cast a text view. Find view by ID r dot ID, and then we'll do first name. And I'm going to say text view last name equals cast a text view view dot find view by ID r dot ID last name. Now the final thing I need to do with this view before I hand the view back off into the list view, I need to fill in my first name and last name text views. So I need to get data. So how do I get, so for this get view method, he's going to be invoked for every single list view item that needs to be presented in the list. I need to get the current customer that is representative of this particular position. So what I'm going to do here is I'm going to say customer equals get item position. And what that's going to do is that's going to retrieve the customer object that is backing this particular list item. So now what I can do is I can say first name.setText customer.getFirstName, and I can say last name.setText.customer.getLastName. And the final thing I do is I return view. Alrighty. This is basically the minimum amount of code to create a simple list adapter. So I hope you guys can see how really flexible this is, because our get view method, we do anything we want. We can hook up images and other list views and whole sorts of really fun things. We could also change the layout based on some condition. Maybe you want even rows to use one layout and odd rows to use another. Maybe we wanted to zebra stripe the items by changing the background image of the view. Really have ultimate flexibility here when you use your own adapter. It's really not that hard or scary. It'll take some time to get used to it, so don't feel too bad if this looks really bizarre, but the more you work with it, the more it'll make sense. So now what I want to do is I want to show you guys how we would use this list adapter. So jumping back into main activity, I'm going to nuke all of this code because all of this code is going away. We no longer need our simple adapter or anything like that. I will keep this though. I'll keep one line of code, and that is the code that gets a reference to our list view. So what I'm going to start off with is I'm going to need a reference to my customer's list adapter as a field in my main activity. So I'm going to say private customer's list adapter. Then, after I get a reference to my list view, I'm just going to leave that up there at the top. We'll use it at the end of this. I'm going to say adapter, so I'm going to instantiate my customer's list adapter, and the only thing that I need to pass in is a context. So pass in this. Then I'm going to say adapter.add new customer, customer1, last name 1. Again, I should have used a loop, but whatever. Okay, so we have a handful of customers that we're adding in. And the last thing I'm going to do is I'm going to say list view dot set adapter adapter. Then what I'm going to do is on my options item selected, you remember my add item menu button that's up on my toolbar? I'm going to go ahead and add some code in here. I'm going to say adapter.add new customer, added customer, added customer. And that's how you use the adapter. So you see, by putting in all the code over here, and instead of shoehorning a pre-existing adapter, such as an array adapter or a simple adapter, we're able to significantly clean up our code. So now we can go ahead and hit play, and we should see this working. And we do. And I can say add item. So now you see our customers are being added with our custom view. So that's really exciting. We can also even come in here and set up the example like it was before by adding a click handler. So I can say set item on click listener, new item on click listener, and then I can say simply adapter.remove adapter.get position. Get item position. So this code will get that customer out and remove it. Now it could remove by position, which would be faster, because we wouldn't have to do a linear search on the array. But the point is this isn't about optimization in this case. This is just showing that when we click on the item, we can remove it from the adapter, and that code will work just like it did before. Okay, so there is definitely a problem, actually, with this code. And the funny thing is IntelliJ is unfortunately spoiled the surprise already. So if you're typing along, you already know what I'm about to start discussing. And if you're looking at the screen right now, you should be getting a good idea of at least where the problem lies. So you notice that lint, which is usually awesome because it tells us to not do stupid things, has spoiled what I'm about to talk about. And that is the layout inflation and the view holder pattern. So ignore that for a second. Let's talk about this method signature. I noticed I kind of didn't really talk about this method signature a whole lot, other than to say the get view item is invoked every time for each list view item, and the position is passed in for which view we should be returning. However, you'll also note that we have a convert view and our parent, which our parent's pretty obvious, but our convert view is really the thing that we want to talk about here. Basically, what we're doing with this code is very inefficient, especially if it's a long list. If our list is particularly long, we have just introduced a huge problem, a huge performance problem, especially when it comes into scrolling. Like, for example, if I go ahead and add a bunch of items and I start scrolling, now you'll notice that there's no performance degradation, and that's just because this is such a simple example. But what's going on here is as I'm scrolling, my getView method is being invoked as items appear, and then the views that are inflated are getting they're getting not erased, but they're getting garbage collected eventually. So basically, as I'm scrolling, I'm allocating a bunch of wasted memory, because as I'm bringing these items into view, I'm inflating that layout. And it's not just about memory here, it's also about performance, because as I'm scrolling up and these items are coming into view, they're being inflated. Wouldn't it be cool if I could reuse those objects? For example, you see right here, my last name 5 guy right there. Imagine that if that if that view goes out of view, that this next added customer item was using the same view, but it took the data of the other customer. So that is what the convert view allows us to do. The list view will pass in the convert view if there's a layout view that's already been instantiated, but it is not visible. And the convert view will simply be whatever view we've been returning. It'll just be a non-visible row. So what I can do is, instead of saying view equals layout and blah, 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 what I can do instead is I can say if convert view equals null, then set convert view to equal the new layout instantiation. Then instead of saying view.findView by ID, do convert view find view by ID. And instead of saying return view, say return convert view. So what's going on now? Now what we're saying is, okay, Android, if you have a row, if you have a list view item that's already been instantiated, already been inflated, and it exists, then we want to use it and simply change the data inside of it by getting a reference to the text views inside of it and then setting those values to the customer's first and last name. However, we are saying also, if you don't already have a view that's already been instantiated, then inflate it right here. So now what I can do is I can hit play. And you're really not going to notice a single difference as far as what you can visually tell on the screen. Just know that as I'm creating items, so I'm creating all these items, when I created all those items, new views were instantiated every time I created those items, because there's no views that are out of view yet. All items are visible at the same time. But if I add a bunch more items, and then start scrolling down, these new rows that are being displayed are being recycled from the views before. So really, there's only a fixed amount of list items ever being instantiated, and now they're being reused when they go out of view. Now there's one more step that we can do to make this performant. And by the way, the stuff that I'm showing you guys isn't a performance operation or a performance optimization that you do when you notice things are getting laggy. What I'm showing you guys is non-negotiable. If you have a list adapter, you must do it this way, and in addition, about the way that I'm about to show you guys. So, in addition to our convert view being cached, we should also be caching our individual text views as well. Why is that? Well, that is because the find view by ID method is not very efficient. The find view by ID method does pretty much a tree traversal of the entire view hierarchy and returns the first view that matches that ID. So it performs a search in linear time, and that is not acceptable when you have a bunch of them in your getView method. When you're invoking findView by ID a bunch of times, it's going to get really, really, really slow. And so what instead you should do is you should do the view holder pattern. You should basically cache these text views into its own object so you don't have to repeatedly do the find view by ID. So how do we do that? So what I'm going to do is I'm going to create a new class. I'm going to say private class, and I'm going to say customer view holder. And for the customer view holder, he's going to have a public text view first name and a public text view last name. Then what I'm going to do is I'm going to modify my code a little bit. At the top here, I'm going to say customer view holder, but I'm not going to assign anything to it just yet. What I'm going to do is right here, if the convert view is null, then what I'm going to do is I'm going to say view holder equals new customer view holder. Then I'm going to say view holder dot first name equals convert view, or sorry, cast to text view, convert view dot find view by ID r dot first name, or r dot ID dot first name. And then view holder dot last name is text view, convert view, find view by ID, r dot ID dot last name. And then this is the important part. So you notice right here how we're extracting out our text views and stuffing them into this view holder. Now I need to associate this view holder to this view. And I do that by saying convert view dot set tag view holder. Then what I'm going to do is I'm going to say if the convert view is not null, meaning we are recycling an already existing list item or list item view, then what I'm going to do is I'm going to say view holder equals cast to customer view holder convert view dot get tag. So notice how we have this this set tag here when we instantiate the view holder, then we have a get tag when we get it back if it already exists. Now what I can do is I can completely remove this code. So now my find view by IDs are only happening once when the view is initially inflated and not happening repeatedly. And so now what I'm going to do is down here where we used to set our text views, I can now say view holder dot first name dot set text and view holder dot last name dot set text. And that's it. So now I can go ahead and hit run, and we will have an efficient implementation of a list view adapter. And again, you guys aren't going to see much of a difference. If I opened up my profiler, you guys would see a decrease in memory consumption after doing this, and a decrease in the amount of time spent each time that a view is accessed. So that's it. If you want the ultimate the ultimate flexibility with your list views, this is how you achieve it. And like I said, using the view holder pattern is non-optional. If you have if a list view, if you have a custom adapter, you must do it this way. If you don't, that introduces needless performance issues. In fact, as you saw earlier, Android Studio itself will actually warn us if we're not using the view holder pattern. Alright, so I think that pretty much wraps up using a custom adapter. At least so far as what we're going to be doing in this before we get into the app. We will see other examples of how we can do other list viewy type things later. But yeah, I guess we'll see you guys in the next video.